Great. So yeah, the title is Thinking Beyond the Default VPC. I was, after submitting my talk, thinking that this could be also like old man ranting about the networks in a cloud, but yeah, now it's a default VPC. Let's see how it goes. So hello everyone, once more. My name is Petri Kallberg. For those who we haven't met yet, quite many familiar faces in the audience. Nice to see you. Like a short introduction why I'm talking about this. So this may explain some things later on. So I have a background from 90s being building this like IT stuff before there was a public cloud, and then later on moved to the cloud, but coming from very much like enterprise background. So please forgive me that. Today I'm AWS fanboy working at Nordcloud. Title is the CTO of cloud infrastructure. So doing lots of this is like a data center in a cloud type of approach, and passionate about like enabling once again this dinosaurs to get right way into a cloud. But that's like a background. So the title was Thinking Beyond Default VPC. So what the heck is default VPC? So that's there in the picture. So around 2009, Amazon introduced this like a VPC concept. So that's like 15 years ago. So there's been like a fair amount of development, and before that, yeah, you were all in the internet. My advice for this is just delete it from not just from your primary region, but delete it from all regions, because the reasons you shouldn't do this. This is like a legacy support type of thing. Don't do this. And there's an interesting detail. So if your company is kind of keen on controlling the traffic, so this is like everybody has their own internet gateways, is something that's not desirable. You can have a IAM policy like this to kind of deny creating internet gateways, but this does no good, because there's a command EC2 create default VPC that will let the Amazon create this default VPC back to you, and it comes with the internet gateway included. So just to like demonstrate my other passion besides the networks, this is like a IAM policies. So yeah, a little bit dark hobbies, but sometimes they come very useful. I didn't know that by the way before doing the slides, so I by accidentally ran to this detail that yeah, Amazon creates it. It's not governed by your IAM policies, but there's an action you can deny creating the default VPC. So what to do instead? I think this is quite basic stuff for most of you, but the most simplest VPC is the one you create yourself, and then you can set, for example, the CIDR range yourself. It's in this one, it's always the same. Every default VPC has the same address space, and that's going to be somewhat difficult. So now you get to choose your own. You typically also do this is like a public-private subnetting thing. So not everything will be accessible from internet anymore, which is kind of a nice feature. You also need to introduce this is like a NATing in your VPC if you wanna gain the internet access from private side of it. And with that, usually you do this like elastic IPs. This routing is still very basic. You have like 2 route tables, and that's about it. But important thing here is that this is not your default, and with that I mean when you have a default VPC, you can deploy stuff and not tell where they should go to. They go to your default, but if you remove the default, then you need to kind of make this conscious decision that I'm going to put my thing into that network. And I would say this is like a good use of time to think where you're going to put your stuff. You don't just throw them somewhere. And this is like a concept that can operate within a single account and single region. So as long as you are fine with that, all good. Then you need to add another VPC at some point. There's a feature called VPC peering. You can kind of route these VPCs together, all good. But you need to take care of this like a routing back and forth. So this might become a little bit like an orchestration problem if you want to do this in infrastructure code, because now you have like two sides and then the peering kind of middle there. You cannot do the CIDR overlap. So if you have two address spaces overlapping even partially, this is not going to work. So need to pay attention like how you allocate your address space. And then this is like a classic thing that you think that if I'm now adding here the third one and another peering, it would somehow magically go through that pipe. It doesn't. You need to do this like a fully connected mesh with the peering if you want a packet to flow. And then first it sounds like a nuance, but there's actually very good reasoning why it doesn't work, because if it would work, you would lose all the control, like where your packets would eventually go to. And this expands your horizon a little bit. So now you can work across the accounts and across the regions as well with the peering connection. So it doesn't have to be a single account, single region anymore. But the network is now like a global. Then you keep adding more VPCs, and then you need to have a transit gateway, which is the box in the middle that you can attach the VPCs and some other networking features like direct connects and VPNs for example. This comes with the added complexity in a sense that now you don't only have routing tables in your VPCs and subnets, but you also have them in your transit gateway, and they can be like multiple ones of those. So gets slightly more complex to manage. You can do simple setups like everything connected, nothing connected with the transit gateway just fine. But if you want to go beyond that, things will get rather hairy. Yeah, and then of course, like peering, you can peer these transit gateways as well, which means that you can expand your network across the regions. When you attach the transit gateway to the VPC, there's like a little detail that you can attach the transit gateway to any subnet, but it would be like a very good idea thinking ahead that if you have like a small dedicated subnet for your transit gateway attachment, and at first it doesn't seem like making a big difference, but then you probably at some point realize that if you have like an attachment and an instance in the same subnet, there's no like a subnet border, and certain things like network access controls list only apply at the subnet borders. So that will limit your ability to kind of control what traffic goes where. So yeah, very good idea if you can have a small. It doesn't have to be very big. The other thing that's like actually written in documentation, but it's very easy to understand in the wrong way. I did this too. Is that when you attach a transit gateway to a VPC, I said you attach that to the VPC, not to subnet or not to availability zone like you do, for example, with the NAT gateways. But you only do a single attachment. You can then have these transit gateway attachment interfaces in multiple subnets, multiple ACs, but it's still a single attachment. And why that makes difference is because the pricing is per attachment, not per AC. And while, for example, the NAT gateways are per that gateway, and you need one for each availability zone. So this can be like a cost point. Why to do the transit gateway and centralized NATs instead of like local NATs. When you control the addresses and the requirement is to have somewhat unique address spaces per VPC, you need something called IP address management, IPAM. You can get that nowadays as a service, which is great. The other thing regarding the CIDR blocks is that you can have like multiple CIDR blocks per VPC, and you can add them later. So first you create your VPC, you create one subnet, 10 something, and then like I said, there comes a new idea that okay, I need an extra subnet, but I already used all my address space with the subnets I created in the beginning. But you can add another CIDR range and create your transit gateway subnets, for example, through that. Of course, there's a caveat here as well, because these like a primary and secondary CIDR ranges, they must have certain kind of relationships. So, for example, if you use the 10 something as your primary CIDR range, you cannot use the same range for your secondary CIDR ranges, but they have to come from certain other address spaces, and this is documented. But like if you are like me, that you only read the first chapter and yeah, I got this, let's go, and then you figure out that okay, for some reason it doesn't work at all. What the heck? There's a reason for it. And then the other thing in this similar concept is that if you are running like a low in your IP4 addresses, which happens every now and then, so your network guys tell you that yeah, we are not giving you any more CIDRs because we are out of them. You can actually preserve your address spaces by allocating the same range across your multiple VPCs, and then have this like a smaller slice that you only expose to your routing. But then it's a similar like this public subnet thing that you need to have a private NAT gateway there to enable the traffic. But doable and might simplify your like a VPC creation experience if you can say that all VPCs can be sharing the same CIDR range, and then when you want to connect them to something outside of other than internet, you add this like a small secondary slice, and there you go. Not very common pattern, but might be useful at some places. And then last, like the obvious pro tip, while you can use the publicly routable IP addresses in your VPC, don't do that. It's like an extremely bad idea. It will make your routing extremely complex, and besides that, it will also break some of the Amazon services, for example, that they don't work for you, and then you go like, okay, well, I did everything according to the manual. I even read the manual this time, and it still says it doesn't work. And that's because the services like I think FSX was one of those. I think it's now fixed, but what was that? You could deploy it, but it's like a SaaS service that Amazon provides the endpoints to your VPC, and they obviously have their own idea of routing, and they route the public addresses to the internet and not to your VPC. So didn't work out very well, and spent like quite a bit time debugging. Moving onwards, there can be this like enterprise environment. It's like idea that we want to have a central egress ingress and probably some firewalls on that route, and this is like a balancing between that. Okay, if you allow to do these internet gateways all over the place, you probably don't have an opportunity to kind of filter incoming and outgoing traffic in any centralized fashion, or not very easy at least, and it's going to probably cost you a bit as well. And then the other way around is doing this. I also already mentioned about the TGW attachment being slightly cheaper option for internet access through central NAT gateways than having NATs everywhere. But when starting to build this kind of construct, it's like extremely easy to, because now you start to have like routing tables all over the place and endpoints and whatnot, and then you have like three ACs. It gets very easy to make routes that kind of hop from one AC to another when packets move from the internet to your service or the other way around, and that's of course is not very advisable. It's going to be costly, and it's also going to be less fault tolerant because now you can lose one AC and then all your traffic for multiple ACs may go with that. While if you do this, it's like a availability zone aware routing, you will only lose like one AC, and the other ones keep working regardless the failed one. But there are some like small details that make this easy to do the wrong way, because for example when you deploy Amazon network firewall and you ask give me the endpoints, the endpoints will come in random order for some odd reason. You can see from the endpoint names which AC these are, but you need to take kind of extra step to make sure that okay, I'm picking the endpoint for ACA, which might be the third one on a list, and put that in routing table A, and not take the first one from the list. And if everybody has ever tried to propose this anywhere, this ingress, centralized ingress can be somewhat sensitive topics between your dev teams, because now you are taking away the ability to deploy new services and expose them to the internet. But it happens through some central proxy. Can be made work, but you need to kind of gain the trust here. And I think this was like an excellent example. This is taken from one of the AWS workshops. So AWS have published these like workshops, and one of them is addressing how the networks are being built, and there was that, okay, we are not there yet, but please use this diagram as a reference. And I think it was quite a bit like overwhelming that, okay, this is where I'm aiming at, especially if you are starting from this, like I just built my first VPC and I have a public and private subnet, and then somebody throws you this. But yeah, that's where it's kind of going. Before wrapping up, a couple of words about the logging, monitoring, and debugging, because the network is always to blame until you prove you are innocent. So that's how it goes. Yes, and there are like tools like VPC flow logs. You can get metrics for NAT gateways, direct connect VPCs. The thing with the NAT gateway metrics is that for some reason you don't have this like how much of the NAT capacity you are using metric. there by default. But luckily, with the cloud, what's metric math, with that allows you to do this like a simple math expressions. You can actually do that. So you can see that, okay, I'm using 85% of my shared NAT capacity. Maybe I should think like some extra here, or have a look why this is so high if it's not to behave as you expected. There's something called VPC reachability analyzer as well, which basically allows you to figure out that am I going to go from A to B, and the beauty there is that it doesn't actually send any packages. It just analyzes your configuration. The downside is that it doesn't really support everything. So some pieces of configuration may be like outside the scope, but it's been made better like day by day. So I think I would call it quite usable at this point. Then yeah, if you're worried about your internet access, there's internet monitoring. Couple of small things in the end. So if you're really into a deep packets level debugging, or just like a monitoring what goes on in your network, maybe some regulatory requirements. There's a thing called traffic mirroring, which basically allows you to mirror traffic to two different places. So packets are not just going where they normally would go, but you can provide alternate target for the packets. So nice tool for this is like a threat monitoring, troubleshooting, but it's also very handy for malicious use cases. So if a bad actor gains access to your account and wants to kind of monitor your traffic between the load balancer and the host where it's typically encrypted already, this might be like an easy way to do that without raising too much attention. So one thing to think about is that, okay, maybe you would like to deny this by default and only allow it when you really need it. Think about it. Other like a small tidbit here is this concept called overlay IP. I wanted to take it here because this is like a typical enterprise software architecture where you have like an IP address that needs to move from one AC to another, and that sounds like an easy thing to do. But then you start thinking, okay, I have subnets, they are tied to the AC. How can I have like an IP address that moves from one subnet to another? And the trick is here to use something that's outside of your VPC address range, and then using the routing tables route that address to your target. Then it can be like anywhere. Most use cases are around like high availability, like SAP guys will do this every time. But you can also use the same trick to route some legacy hard-coded IPs. So you have some clients that have a hard-coded IP where they call each and every time, and the source code is being lost. And now we are moving this stuff to the cloud. This could be one way of doing it. Originally I want to talk about VPC Lattice, which is kind of the service network for like a common people instead of just containers and cube. This sounds like an awesome idea, and especially I like the point that you can build this like a service network and connect your EC2s and stuff to that without any agent or sidecars. But then I was like seriously let down with the last bit that there's okay, only HTTPS and RPC are supported. So maybe one day in future they would do this like an NLB type of lattice setup, which would allow you to do all network in service mesh, and then actually all this stuff about this VPC design and that would become mostly irrelevant, which I certainly hope will happen. And then maybe one last idea that, okay, do you need a VPC at all? There's plenty of services. If you do this like a hardcore serverless stuff, you don't need to build your own VPC. But as they say, it's still in somebody else's network. If you wanna continue on the topic, there's like every reInvent has this like a net 3 something where they go hour-long speed run through how the VPC and network have evolved since last time, and usually changed all the best practice since the last year. So you are kept busy. But I think we are about the time. Is there any time for comments or questions, or what the heck?
Yeah, well, we have quite a tight schedule. We need to run to the next one, but maybe you can stay around, and the next speeches are going to be 10 minutes long, and then we have a longer break after that. So
absolutely happy to discuss if you feel strongly about these things one way or the other.
Yeah.
Hey,
thank you, Petri.